Welcome back to Neural Intel. It's amazing to see all of the advances happening in AI. Today, we're diving into something that really caught my eye.
Oh,
It's called VLM-Attention, and it's making some serious waves in the world of game AI, specifically in StarCraft II.
StarCraft II. That's a great testing ground for AI, isn't it?
It is. It's a really complex game, strategically speaking. And this VLM-Attention, it's pushing the boundaries of what we thought AI could handle in that kind of environment.
So what makes VLM-Attention different from, say, the AI we've seen in other games like chess or Go?
Well, with those games, the AI typically relies on a simplified version of the game, right?
Right, a sort of abstract representation of the game state.
Yeah, exactly.
Yeah.
But with VLM attention, things are different. The AI is actually processing visual information from the game. It's literally looking at the screen.
Wow, that's interesting. So it's not just working with a bunch of numbers and data.
Nope. It's actually seeing the units, the terrain, the whole battlefield. And it's combining that visual input with natural language descriptions.
Natural language. You mean like sentences and phrases?
Exactly. So, for example, the AI might receive a description like, 3 Marines are engaging a zealot at these coordinates.
That's a pretty cool concept. So it's getting this multimodal input, both visual and language-based, and that's helping it to understand the game in a more human-like way.
That's the idea. And it seems to be working. The researchers have seen some really impressive results.
I bet. But how does this VLM attention framework actually work? How does it go from seeing and understanding to making strategic decisions?
Well, there are 3 main components at play here. First, there's a self-attention mechanism.
Self-attention. What does that mean in this context?
It basically helps the AI figure out which units on the battlefield deserve its attention at any given moment.
So it's prioritizing targets. Like, okay, that siege tank is about to fire. I need to focus on that.
Exactly. Then there's the knowledge-enhanced decision system. This part uses something called ARG, or Retrieval Augmented Generation.
Arg, that sounds interesting. What is that?
It basically gives the AI access to a huge database of StarCraft II knowledge. Things like unit stats, counter strategies, typical tactics, that kind of stuff.
So it's like the AI has a StarCraft strategy guide built right into its brain.
You got it. And then the third component is all about coordination. It's called a dynamic role assignment framework.
Dynamic role assignment. I'm intrigued. Tell me more.
So this helps the AI manage multiple units effectively, making sure they work together as a team, instead of just running around like a bunch of chickens with their heads cut off.
Right, because coordination is super important in StarCraft. You need to be able to attack as a group, defend strategically, that sort of thing.
Precisely. And this dynamic role assignment framework helps the AI do just that.
Okay, I'm starting to get a picture of how these pieces fit together, but can you walk me through like a typical decision-making sequence for the AI? Like what actually happens step by step?
Sure. So let's say the VLM agent receives an observation from the game. It sees what's happening on the screen, gets the language descriptions, and has all the data about the units in its view.
Okay, so it's taking it all in. What next?
From there, it first analyzes the overall situation. It tries to figure out what's going on and develop a sort of initial skill plan.
So like a high-level plan of attack or defense.
Exactly. Then it uses that self-tension mechanism we talked about to identify the most important units, the ones it really needs to pay attention to.
Got it. So it's zeroing in on the key players, the ones that could make or break the game.
Right. And then it uses Array to pull up any relevant information from the knowledge database about those units.
So it's doing its research on the fly. Like, okay, that Banshee can do a lot of damage. I need to watch out for that.
Precisely. And finally, taking all of that into account, it decides what to do.
So the visual input, the language, the knowledge from the database, the initial plan, it's all feeding into this final decision.
That's right. And it's all happening incredibly fast. It's amazing to see in action, really.
That sounds like a lot of processing going on. I'm impressed. But does it actually work? Like, does this VLM attention approach hold up in real gameplay?
That's a great question. And to answer it, the researchers put these VLM agents through their paces.
Oh, how did they do that?
They designed 21 custom micromanagement scenarios, each with different unit compositions, tactical challenges, and even the use of special abilities.
So like a series of mini battles, each testing different aspects of the AI's ability.
You got it. And the results, well, let's just say they were pretty impressive.
Okay, now you've really got me hooked. Tell me more.
Yeah, the VLM agents did really well in a lot of those scenarios,
Yeah.
especially the ones that focused on like basic tactical concepts. Things like focusing fire on the most important targets and coordinating
Oh,
movements.
so like the fundamentals.
Exactly. But, like any AI, they did run into some problems in certain
Yeah, I
scenarios.
was just thinking about that. Like, what kind of challenges did they face? Let's see. They had trouble with the scenarios that required really precise timing, like, you know, using abilities at just the right moment.
Oh, yeah, that makes sense.
Yeah.
I mean, that's tough even for experienced StarCraft players.
Yeah, exactly. Or those really intricate maneuvers, like getting your units to move through tight spaces without bumping into each other.
Oh, yeah, that spatial awareness thing. We talked about that a bit earlier, right?
Yeah, yeah. So, the takeaway there is that while these VLM agents are doing some amazing things, strategically speaking, they're not quite ready to take on professional StarCraft players just yet.
Okay, so they still have some room to grow.
Hmm.
But it sounds like even with those limitations, the results are pretty promising.
Yeah, absolutely. And to really appreciate how significant these results are, you have to compare them to like traditional approaches to game AI.
Oh, right. Like those older methods that use, what was it, simplified representations of the game state.
Right, exactly. Like that cheat sheet analogy we talked about.
Yeah.
And those methods have had some success, but they lack the depth and nuance that you see in human players.
Right. So it's like they're playing a different game.
Yeah, that's a good way to put it. And what's amazing is that even though VLM-Attention is a relatively new approach, it's already performing comparably to those older, heavily trained methods.
Oh, wow. Really? So you're saying they're achieving similar results without all of that intense training?
Yeah, that's right. And that's a big deal because it suggests that this approach is inherently more efficient and potentially way more powerful in the long run.
Wow. So it's not just about playing the game more like a human, but also about learning and adapting more effectively.
Precisely. That's where the real potential of VLM-Attention lies. It's a totally different way of thinking about and designing AI.
Okay, I'm starting to see the bigger picture here. This isn't just about StarCraft. It has implications for, AI in general.
Absolutely. But, it's important to remember that there are still some challenges to overcome. We talked earlier about some of the limitations of these VLM agents.
Right, like that spatial understanding thing being a hurdle.
Yeah, and that's about more than just knowing where things are on the map. It's about understanding the relationships between units and terrain. Knowing how to use the environment to your advantage.
So things like knowing when to position your units on high ground.
Yeah, exactly. Or using choke points to funnel enemy forces, things like that.
Right, right. So basically, they haven't quite mastered the art of terrain manipulation.
Yeah, that's a good way to put it.
So what are some other challenges that researchers are, working on right now?
Well, another big one is real-time control. StarCraft II is a super fast-paced game. Decisions have to be made in a split second.
Yeah, like playing chess at warp speed.
Uh-huh, yeah, something like that. And while VLMs are getting faster all the time, they can still struggle to keep up with the demands of real-time decision-making.
Okay, so they need to work on their reaction time, basically.
Yeah, you could say that. And then there's the issue of applying knowledge. Remember we talked about that huge database of StarCraft knowledge that the AI has access to?
Yeah, the strategy guide in their brain thing.
Right. Well, they don't always apply that knowledge correctly.
Oh, so it's like they have all the textbooks, but they don't necessarily know when to open the right one.
Uh-huh. Yeah, something like that. They might misidentify a unit or misread a situation. They make decisions that don't quite line up with the information they have.
So there's this gap between knowledge and action that needs to be bridged.
Exactly. And that's one of the things that researchers are actively working on.
It's amazing to see how much progress has been made in such a short time.
It really is. And I think we're just at the tip of the iceberg with this VLM-powered AI.
Yeah, it sounds like it.
Yeah.
But before we move on, I wanted to go back to something you mentioned earlier. You said that VLM attention represents a different way of thinking about AI.
Mm.
Can you talk more about that?
Oh, yeah, sure. Traditionally, AI research has been all about creating systems that are very specialized for very specific tasks.
Right, like an AI that can beat anyone at chess but can't do anything else.
Exactly. And that approach has led to some impressive achievements, but it's also limiting, right?
Yeah, like having a toolbox full of specialized tools, but no Swiss Army knife.
Uh-huh. Great analogy. VLMs, on the other hand, are moving towards more general purpose AI.
Wow.
AI that can handle a wider range of tasks, more like how humans think and learn.
Right, right. And VLMs, they're designed to process both visual and language information, which are like the two main ways that humans interact with the world.
Yeah, exactly. So it's like giving AI the ability to see and read at the same time. And that's why this VLM attention research in StarCraft II is so important.
Yeah, because it's not just about building a better game-playing AI.
Right. It's about exploring the potential of VLMs to solve all sorts of complex problems. Problems that are more like the ones we face in the real world.
So it's a stepping stone toward more versatile and adaptable AI. AI that can learn and evolve in more complex and dynamic environments.
That's exactly it. And the things we learn from these experiments in StarCraft II, they'll definitely have ripple effects in other fields too.
Like robotics and natural language processing.
Yeah. Even scientific discovery, potentially.
This is incredible stuff. But I bet there's even more to talk about.
Huh.
What can our listeners look forward to in the final part of this deep dive?
Well, we're going to dig into some specific research findings that really showcase the power of VLM attention. And we'll talk about some exciting avenues for future research and development. So stay tuned.
Welcome back to Neural Intel. It's really amazing to think about how far AI has come, especially with this VLM attention research.
I know, right? It's like we're on the verge of something huge.
Yeah, and speaking of the future, what do you think are the next big steps for this VLM-powered AI? Like, what are researchers focused on right now?
Well, one thing they're definitely working on is refining the whole VLM attention framework, making it even better.
Oh, right. Because we talk about those challenges like the spatial understanding and the real-time control, right?
Exactly. And researchers are coming up with new techniques and architectures to address those challenges.
So basically making the VLM agents even smarter and faster.
Yeah, pretty much. And another big area of focus is looking beyond StarCraft II, figuring out how to apply this type of AI to other fields.
That's really interesting. So what kind of applications are we talking about? Like self-driving cars?
Robots. Oh, yeah,
Yeah.
absolutely. Imagine robots that can navigate complex environments using both vision and language, just like humans do.
Wow, that would be incredible.
Yeah.
So it's not just about mastering video games, but about developing a whole new way of thinking about AI.
Exactly, a way that's more aligned with human cognition. Now, shifting gears a bit, let's talk about some of those unexpected capabilities that emerged from the research. The things that surprised the researchers.
Yeah, I'm really curious to hear more about that.
Well, one thing that really stood out was the AI's ability to prioritize units strategically. They learned to focus fire on high-threat units or target low-health units to maximize their damage.
Wow, so it wasn't just reacting randomly. It was actually making strategic decisions about who to target first.
Yeah, exactly. Like it understood the bigger picture.
That's impressive. What else did they find?
Well, they were also surprised by the AI's ability to develop what they call multi-unit synergies. So basically coordinating attacks with different unit types.
Oh, wow. So like having Marines and siege tanks work together?
Yeah. And the AI figured out how to position the units to maximize damage while minimizing friendly fire.
It sounds like they were coming up with their own little battle plan.
Yeah, it was pretty amazing to see. And then maybe the most surprising thing was the AI's ability to adapt its tactics based on the situation.
Oh, right. So they weren't just following a set of pre-programmed rules.
Nope. They were learning and responding in real time. Like they would adjust their aggression level based on whether they had a unit advantage or disadvantage. And they even factored in the terrain when positioning their units.
Wow. So they were developing this kind of battlefield awareness. It's incredible to think about how much they were able to learn just by playing the game.
I know. It really makes you think about the nature of intelligence and how we can replicate and even enhance it through AI.
Yeah, it's pretty mind-blowing. So as we wrap up this deep dive, what's the one thing you want our listeners to take away from all of this?
I think the biggest takeaway is that we're at a turning point in AI. VLM attention is just one example of how AI is becoming more human-like in its thinking and actions. And that has huge implications for the future.
Absolutely. Yeah. A future with incredible possibilities and, some challenges too. But one thing's for sure, AI is advancing at an amazing pace.
Yeah, and if you want to learn more about this research, be sure to check out the link in our bio. You can find the full paper there, along with some really cool demos and visualizations.
Yeah, it's definitely worth checking out. Well, that wraps up our deep dive into the world of VLM attention in StarCraft II. We hope you enjoyed it.
Yeah, thanks for listening.
And we'll see you next time on Neural Intel.